solar constant. Solar constant. Solar energy reaches the earth purely by radiation only. Means sun's energy reaches the earth is only in the form of radiation. By applying the heat transfer relations and geometrical shape, the average radiation from sun reaching the earth could be worked out. This is called solar constant and is equal to the 1353 watt per meter square. Now another definition of solar constant is defined as the energy received from the sun per unit time on a unit area of surface perpendicular to the direction of propagation of the radiation at the earth's mean distance from the sun outside the atmosphere. Solar constant is denoted by the ION, and the latest value of ION is 1395 watt per meter square. But World Radiation Center, or we can say WRC, has adopted a value of ION, or value of solar constant is 1367 watt per meter square. Now, based on the solar constant, as we know, based on the solar constant, the total solar energy incident on the entire globe of Earth would be calculated. So, from this ION, we can easily find out the total solar energy incident on the entire globe. From this, we can infer that the total radiation received from the sun is enormous. As we know that the solar constant or extraterrestrial radiation varies with the time of the year and due to variation of radiation emitted by the sun. So as we know, in various seasons, the sun rays coming to the earth or reaching to the earth's surface is not constant. So the solar constant value is variable. So that the approximate equation relating the variation of sinusoidal solar constant with time of the year is, this formula is ION is equal to ISC into bracket 1 plus 0.033 into cos of 360 n divided by 365. In this formula, the ION is the actual sinusoidal radiation measured by the plane normal to the radiation. Next is ISC. So what is meant by ISC? ISC is the solar constant taken as 1353 or 1353 watt per meter square, and N means number of days of the year, means how many number of days we can calculate the solar constant. Okay, next point is sun's radiation. Sun's radiations are of two types. The first type is beam radiation, or we can say direct radiation. From that name, we can say this radiation is in the form of beam or in the form of only a light or direct light. So in that beam radiation, sun rays travel in straight parallel lines. These are radiations received at the Earth's surface without change in direction. Sunlight through clear sky has beam radiation. So if in the sky no clouds are present, means we can say a clear sky has been clear sky. At that time, this direct radiation or beam radiation reaching to the Earth's surface. Then second type is diffuse radiation, or we also say that scattered radiation. From that name, we can easily understand This type of radiation is diffuse type, or is spread out the spreader radiations. So in that, those radiations received at the Earth's surface from all parts of the sky's hemisphere after being scattered in the atmosphere. Scattering of the sun rays takes place in atmosphere due to atmospheric dust, gases, vapors, etc. Means scattering of sun rays occurs mainly due to the atmospheric dust, gases, vapors, or the pollution. We can say pollution, smoke, at that type of impurities available in the sky is the reasons for the scattering of the sun rays. Next point is global radiation. Global radiation is the sum of beam radiation and diffuse radiation. So simply we can say global radiation is the addition of beam radiation and diffuse radiation. Means global radiation is the total radiation occur in the world. So global radiation is equal to beam radiation plus diffuse radiation. Global radiation is also referred as insolation at a particular point. The radiations received by the collector surface are always global radiations.